Hello, everyone. Thanks a lot for being today on this webinar. This is a repetition of the webinar developed this morning, where we have some technical issues with the recording, so we are repeating this to be available on the website. Today's presentation will be around the EXP polyvalent heat pumps from RHOSS. We're going to be explaining you the basis of the EXP polyvalent system, 2-pipe, 4-pipe, 6-pipes, and how to use the advantage, disadvantage, and how these compare with standard heat pumps. We acknowledge the support of EcoHSPAC, our exclusive agent for Queensland, Canberra, and Sydney, and for us, helping us together with the team to actually prepare this presentation today. So without losing a little more time, we start our presentation. So just a little bit of myself. I've been working with the TechIN since the company startup. I'm a mechanical engineer, specialized in refrigeration and air conditioning. Over 13 years doing this kind of project. I started my career working in refrigeration with an Italian contractor called Friotecnica Internazionale. We were doing systems like CO2, auditors, and refrigeration system. Since I landed in Australia about 10 years ago, I started to design critical air conditioning system when I get really involved with healthcare and data centers. And today we develop, of course, everything related to heating and cooling when we have RHOSS as a main brand. So that's a little bit of myself. I'm not going to be spending more than probably 4 or 5 minutes explaining who we are, what we are, and how you can contact us, because we have 45 minutes to do the presentation. I will want to spend that more time with you. What you see in front of you is what I call index, but that's the learning path that I have to you today. After you leave this presentation, I want you to be aware what does it mean to design or to have a 2-pipe system, with domestic hot water. What is a 4-pipe system? When and how to use EXP RHOSS polyvalent system, and what are the advantages and disadvantages when you compare this with the new heat pump in the market with total heat recovery. And of course, we finish with some advice at the end. So a little bit about RHOSS. RHOSS is not a new player in the market, has been here doing HVAC solutions since 1968. That were represented, of course, in Europe, here in Australia. In 2018, they celebrate 50 years. At the moment, they count about 300 people in the headquarters and the manufacturing facilities in Cotrocco, near Venice, in Italy, and with a annual turnover for about 7 million euros. Recently, when I say recently, starting in January 2019, RHOSS Group was acquired by the new NIBE Group. That's a Swedish company, and actually came with something amazing, because NIBE is a group that is expanded their climate division of the HVAC and R divisions, and RHOSS is one of the key companies doing this. NIBE is a company started in 1949. It's also not a new company in the market, with more than 15,000 employees around the world and have turnover close to 2.5 billion euros. It is good to know that NIBE is a company investing about 10% of the annual turnover in new companies. But the good thing about NIBE Group is that actually they acquire the new company, but they keep their independence. In other words, RHOSS is a totally independent company, able to think by themselves how to develop their range, what is the best future for RHOSS, and how we're doing this successfully for the last 50+ years. A little bit about us. So we're an Australian company, and we are a dedicated company for HVAC and R. Yeah, we are a product distributor, but we do not consider ourselves HVAC and R distributor. The main reason for that is because we believe everyone can be a distributor, but we use our internal and local engineering department to help you to get better solution into your project, but at the same time, we are that bridge between your project and the R&D department of our manufacturing facilities, that together we can do book number of gray matter and years of experience that can give you something better. So what we do is we basically cover all main equipment from A to Z in the HVAC and R, and we specialize on RHOSS and heat pump with chillers and heat pump with RHOSS, but we also do data center and healthcare facilities or critical air conditioning. How you can contact us? This is RHOSS. Basically, you are well represented by a TechIN. We're the exclusive distributor of RHOSS in Australia, and we have appointed EcoHSPAC to be our exclusive agent for Queensland News as well, and the Australian Capital Territory. Something that I would like to clarify is TechIN is a company that complies, and we're always taking care of all the national standard certification in energy efficiency, pressure vessels, anything related to the brand. And actually, we are the ones supporting you 100% with service and also with the warranties. EcoHVAC work together with us, and we want to remove the idea that we have a middleman. No, as TechIN, we warranty nationwide, competitive price, the same price for all the states. What we want is to be closest to you. And having EcoHVAC as a right partner with all the experience and the employees and engineers they have bring to TechIN, RHOSS, and EcoHVAC actually a very profitable relationship that we want to stand to you. Moving a little bit forward, something is very important. Yeah, RHOSS has one of the most incredible qualities in chillers in the market at the moment. But once you have selected the best chiller heat pump solution for your project and developing a good design, it's important to have a service agent or someone that's able to service, commissioning, and support your unit for the life of the equipment. So we do that. We do have service agents in every state, and we do train them locally, and we do train also them at the factory. What you see there is only some pictures referring to the latest training that we developed at the factory. If I remember well, was last year, and we actually were developed training specifically also for 4 pipes. The main reason is we believe that Australia finally is waking up for this kind of technology, and we're actually looking forward to support you, but we need to have the infrastructure that we already have. Moving forward, what is RHOSS? What is our core business? Basically, we manufacture heat pump and chiller from A to Z. We can cover any capacity between 5 kilowatt to 1.7 megawatt, going through basically every compressor style at the market. We can do scrolls, we can do inverter scrolls, we can do screws, we can do inverter screws, we can do centrifugal compressor, we can do air-cooled chillers, water-cooled chiller, free cooling, EXP, and we're going to be talking today about the polyvalent systems. That is basically on the top. Something very important that you see there on the middle on the slide is Eurovent certified. RHOSS is a company of what we like to consider, and it is a Eurovent certified all. That means that all the range that goes in between the range and parentheses of Eurovent, we are fully Eurovent certified. But even more important than that is related, RHOSS has one of the bigger R&D labs certified by Eurovent. In other words, we certify our own, but we can also certify our competitors, any other brand, any other chiller. So actually, RHOSS is selling this kind of service in the European area. Something that you see 2 pictures there. Please do not get confused. On the top right, you can see testing room. So in this case, number 1. This is not the lab. This is the actual manufacturing line testing. This is something very good. First thing for the kind of equipment, it's a pre-commissioned equipment, pre-charged with refrigerator, pre-tested. We test at the end of the manufacturing line, regardless the capacity, regardless the style, we test every chiller. It could be 5 kilowatt, could be 1.7 megawatt. Every chiller you can rest sure is totally tested at the factory before it's landed in Australia. Sure. What you see in the bottom is the entry to the lab. It's a different scenario. In this lab, we can simulate any environment condition between relative humidity and temperature between 50 degrees. In other words, we can simulate any Australian condition even before the chiller leaves the factory. If we can program with the test at the factory, what if you have an important project and you want to see the chiller already running there at any condition, we can simulate that, and you can actually go to Italy, have a good look of your machine that you have been ordered to us. Moving forward, that's basically a bit of what we are, who we are, how we can contact us, and how close are to you here in Australia. But because we have a lot to digest during the presentation, I would like to move a little bit quicker into it. So let's think about 4 pipe. Let's think about energy efficiency. If we think that, we think about a building. The picture you see there is basically showing all the kind of uses that you can do for heating and cooling inside a building, and most of the sources that you can get it. You can use chillers, you can use reversible heat pumps, you can use boilers, you can use geothermal. Geothermal in Australia is not that common yet. I've seen not too many projects or consultants interested into that. But the most important thing is you can see a lot of different forms of energy and what you're gonna get heating and cooling. And normally, you having a separate system for cooling or a separate system for heating does not mean that it's going to be integrated. What I see in overall is when you have an independent system, could be energy wasting, and maybe you are decreasing your energy efficiency. That is good for Australia that now we're waking up. I remember when I started to promote EXP polyvalent pump, RHOSS is one of the pioneers. We have been doing it for plus 18 years, since early 2000s. And 8 years ago, I started to talk with some consultants, some contractors, and we were not interested. First thing, we're used to use boiler. Second thing, even we only until a few years ago, we're still being allowed to use even electric heating in your handy unit in building. I don't think so now you can replace an old electric heating with another electric heating when you're doing a retrofit, but we still have many air handy units running with electric heating around. So now Australia is waking up, and this is the reason we're preparing this kind of presentation. So how a 4-pi EXP system can work is exactly that, when you're trying to combine independent or simultaneous cooling and heating demand. That's exactly what an EXP is here. An EXP unit is no more what we call a smart heat pump with a smart heat recovery, when you can get cooling only, heating only, cooling and heating in exactly any season, it could be winter, could be summer, and it will be automatically done by the machine. All right. So that is something that keep that in mind. You're going to have the complete satisfaction, and you're going to be meeting capacity for heating, cooling, independent, or simultaneously. So let's go to the basic. So this is exactly when I want you, this is a problem, in my opinion, we have in Australia, all the understanding. We were not used to use heat pumps. Now we're using heat pump, and suddenly we have a smart heat pump, and the people start to talk about 4 pipes. So 4 pipes, in my opinion, it is a wrong way to call this unit. That is started to get messed. If we're talking in a background like European background, they're used to use heat pumps more than us. It's easy to them to understand it. But when you have maybe smart engineer, could be younger, could be senior engineers, and you start to introduce this concept, but only by making some misplacement of the concept, you can get it up in a big mistake that I will be explaining in further ones. So that is the reason I try to focus first in the 2-pi system. I know you're gonna say, I know that. Many of the people that we have been doing this kind of presentation, we're engineers, we are designing, we know that it's a 2-pi system. But it won't hurt to go one-to-one in order to teach you the difference. So a 2-pi system, let's consider we're using an air-cooled chiller or an air-cooled heat pump. Is no more when you have matching the pipes that you have in front of the unit into your system. We call it 2-pi. For say we are in summer mode, and we're producing chilled water, maybe 12 to 7, standard condition in the Australian industry. You have an inlet connection, one outlet connection, you have 1-pi system. We use that for air conditioning during summer, use that for heating during the winter, all right? But this is when it gets confused. Is we say, okay, I'm gonna be counting only the pipe connections, water, hydronic connection that I did to my system, and I can define I have a 2-pi system. Yes and no, that's the correct answer to that. Because imagine now, instead of using an air-cooled unit, could be heat pump or chiller, we want to use a water cool because we have a cooling tower. Suddenly you're going to receive, let's say for us, for RHOSS, a water cooled heat pump or water cooled chiller with 4 pipes to be connected to the system. 2 in the primary circuit, what we call supply for chilled water or heating water, but 2 will be related to condenser water. They could be going to cooling towers, or they could be going to an adiabatic system, or whatever you have to reject your heat into the environment as a water cool system. So now I have a chiller or a heat pump that have 4 hydronic connections to be connected. So is this a 4-pi unit? And the real answer to that is no. First thing, please get out of your mind, disregard the idea that the 2-pi going for the water cool condenser are not related to this kind of nomination. And this is exactly what I'm telling you, that I hate this name. It's starting to get confusion in the market. That is the reason, if we have the possibility that we're introducing this new mine into the Australian market, it will be idea that we start to call this correctly. It has to be called, when you want to refer to 4-pi or this kind of system, we say polyvalent system, or we say multi-purpose system, heat pumps, all right? Moving forward, you can have an idea. Look at, I know when I'm producing chilled water or when I'm producing heat pump, I project some of that heat into the environment. So in one way or another, you're wasting free energy. So I'm thinking I may have a scenario, it could be an hotel where you are probably trying to have an air conditioning system during summer and winter, but you want to have a domestic one, right? So you say I can put a heat recovery in the chill water of the chiller, or even in the heat pump, and I'm going to start to recover maybe temperature between 45 to 55, and I'm going to use that hot water to my domestic water or to any other heating water design that I have inside the building. So first thing, is this system now called a 4-pi? Okay, starting from the beginning, let's keep it simple. It is an air-cooled version. So we have 2 pipes to be connected in and out to the primary circuit. Could be 12 to 7 if you're cooling, 45 to 55 if you're heating, like a heat pump. And now I have a heat recovery. So that means I need to connect 2 pipes that are producing hot water. Should I need this to call 4-pi? This is what is called 4-pi. And the answer short to that is no. This is not what it is. It's still been a 2-pi system with a heat recovery. Why we have to use a boiler there? Because you can use a boiler to replace the heat recovery and you get the same situation. Or even if you need to keep in mind when we're doing heat recoveries, total heat recoveries in units like this, because of the refrigerant tile, compressor, and many other compressors that you get inside the system, to get as a variable, maximum reliable temperature you can get is about 55 degrees. But if you want to replace a boiler that normally goes to 70, 75, 80 degrees, you may need to use a makeup boiler. So now we have an air cool with 2 pipes connected to the primary system. Here you may have a heat recovery. It is called a 4-pi. Yes, if you count the pipes are 4-pi, but I don't like to call this a 4-pi system, because what the people understand when they need a 4-pi system is when you need simultaneous or independent cooling and heating. And this is actually the next scenario we want to analyze. So what is a 4-pi system? What is a 4-pi design? Is exactly that. Depending on, it could be that picture you have there, you are in the mid-season, you have one phase of the building at the sunlight, so you're getting heat there, you may need air conditioning. The other side is in the shadow, you may need heating in different offices. So it could be a system where you can have an independent or simultaneous demand of heating and cooling. At this stage, we're talking about only the system. We are not talking about the EXP system, polyvalent technology, or RHOSS. It's the demand, we're talking about the system. How you can satisfy that demand. As normal, what we do in Australia, you can use a chiller to supply the chill water, and you can use a boiler to supply the hot water. So you have basically independent demand of together. They're totally independent systems, but you can be losing efficiency as overall. You can start to use a chiller with heat recovery, and that will give you a little better efficiency, but you may need a boiler when you need independent only. I say that because when you're not using an EXP polyvalent system type that we're going to explain you in the next slide, if you have a chiller with heat recovery or a heat pump with heat recovery, there is something important you need to imagine. There are 2-pi systems, that means if heat recovery call that. But if for any reason you want only heat, you cannot get only heat, because you need a demand of cooling to be able to get heat recovery. And this is exactly when it gets messy, when you use a simple system. So in simple system or a polyvalent unit, to get heat recovery, you need to run a demand of cooling, run the compressor, or a demand of heating, you are need reversible heat pump. There are new class of heat pump. They are a little bit smarter. They can give you some advantage we want to explain at the end. But keep that in mind that generally speaking, with any manufacturer, in order to have heat recovery, you need a demand of cooling or heating. Moving forward, what is an EXP technology? It's exactly that. It's basically a smart heat pump that is able to comply any possible situation coming from a 4-pi system. If you need only cooling, if you need only heating, and if you need simultaneous heating and cooling. Keep that in mind. The next slides are going to become a little bit more technical, but a little bit more interesting, because I will explain you how one unit, an EXP RHOSS unit, can satisfy that in automatic way, automatically by the controller. In other words, the only set point you need to set in one of the EXP units from us is what is the outlet temperature you want out of the unit. In heating, let's say 55, and what is the outlet temperature you want out of the unit. In cooling, let's say 7. Yeah, I do a parenthesis. You can also, depending on how you want to control the system, you can set, or you can control the outlet or the inlet. We can do both, and I like to more to control the outlet out of the unit. So when we focus in 4-pi units, And now we are inside RHOSS. Inside what is speed technology is a 4-pi unit. EXP unit is an MR heat pump out of RHOSS. That is an hybrid unit able to comply all the situation, optimizing energy, avoiding already use the use of fossil. You may not use the boiler that often and increase system efficiency. So we can do 4-pi system and we can do 6-pi system with this kind of unit. Actually, we also can do 2-pi system. We can cover all the range. These kind of units out of RHOSS have two modes. The one we call automatic and select, right? Automatic mode is basically we prioritize the production of chilled water. The unit will run most of the time as a chiller. And when in select mode, we are prioritizing the use of hot water. You see some identification there between the main heat exchanger and the recovery heat exchanger and where the water. I bet you, please, the information is there, is correct, of course, but it's a little bit confusing. I did something over the weekend in order, after I've been in the factory, let's say more than 8 times, I've been trained in this equipment, I've been working with this equipment, but every time, I don't know, is the way we think in Australia, the European way is a little bit different. They are more used to when they say main heat recovery, secondary heat recovery. I was getting the idea, but I was not getting the idea at the same time. I don't know if you get my point. So that is the reason we're engineers, so I went to the basic. I'll ask them what is happening with the refrigeration circuit. So they show me the refrigeration circuit. They show me what happened with the refrigeration, with the refrigerant, and I could able to understand when the system worked in 2-pi, 4-pi, or 6-pi. All right. By saying that, so I asked permission. I'm going to show you a real refrigerant circuit. We have removed all the know-how, basically from the RHOSS. It's a very simplified version of the refrigerant circuit, but I think it's going to be very useful for you to understand how one unit can comply with the 3 scenarios. All right. To do that, let's review the basics. I'm pretty sure you are more than aware than myself regarding this kind of, this is the vapor refrigerant cycle that we all know. We have the high pressure side, the low pressure side, we have the expansion device, the compressor, and we have the evaporation and the condensation of the refrigerant. It's pretty important to keep this in mind because we have this concept clear, we're going to understand exactly what happened inside the EXP unit. So, scenario 1, as I say, we have automatic and select mode. We are in automatic mode when we are prioritizing the generation or the production of chilled water, and we have 3 modes: automatic 1, automatic 2, and automatic 3 that we're going to be defining in different ways. All right. On the left, I still have the old school, what I like to call the old school, how factories used to show this. All right. And they are telling you in automatic 1, we're producing only cool water by the main heat exchanger. But what I did is, I look for one independent circuit, but you see there on the right, the refrigerant circuit of an actual EXP RHOSS unit, all right? And if we remember that basic cycle that I showed you before, we say, okay, in automatic mode, what happened is automatic 1, the unit by itself, I already have all my electronics that I will show you, also the water circuits. I have everything connected. I have a water tank connected for cool and cold water. At this stage, let's say we are in summer, this is probably instant in an hotel or in your builder, and you only have required for cooling. Let's say you need to keep your water tank at 7 degrees, and you need to have your hot water tank of 50 degrees. 50 degrees, okay, the tank, we are satisfying that requirement. The water tank for the cooling is going to 8 to 9 to 10 degrees. The chiller pick up the delta T different, and they say, look, Ahmad, I need cooling. At that time, the chiller by itself will decide to run in a refrigeration circuit 1. What I say, look at the main heat exchanger, that in this case becomes like the main evaporator. We have 1 or 2 pies. The unit is working only as a 2-pi system automatically. It's generating cool water maybe from 12 to 7. Inside that heat exchanger, that refrigerant is getting vapor, is getting to gas, going all the way, playing by the 4-way valve, going to the compressor. We're going to the condenser after. We reject the heat. We're getting heat from the water and through the work, the compressor, of course, to the environment. We go back to the expansion device and we repeat the cycle. Basically, unit by itself has decided to run as a chiller. It has decided to run as a 2-pi system. But how that would look like in the actual water side. In this simulation we're doing now, we're doing this. This is a generic water connection with all the valves. we're using a chiller EXP with 2 circuits. Let's imagine that. You see the requirement on the top left, sorry, on the bottom left. There is 100% demand of cooling, 0% demand of heating. In that moment, we're working as a standard chiller. Both circuits are cooling the water, and we're rejecting the heat via the air-cooled condenser. Looks pretty simple now. Right? Now we're getting to middle season. We're getting into maybe September, October, when we have that middle season, so it could be a demand. So now imagine that your chiller still, look at in the cooling side, my water tank is going still to above 7, so I still need cooling. But at the same time, we're starting to use that heating. It could be an hospital when you're using heating even for dehumidification reasons. It could be, or probably you're using the heating because you are in the mid-season. For any reason, your design is now required to heat the water tank on hot water and to still have cooling water. So in that moment, the unit by itself senses the difference. You don't need to do anything. Say, look at, I need heating and I need cooling. So by the cooling, I'm still using the evaporator, main heat exchanger. As for cooling, 1 or 2 system, 2-pipe system there, we evaporates, we get gas onto the refrigerant. We're still using the same way going to the compressor. Main difference, now before well above, swap the information or swap the refrigerant from the air-cooled condenser into my heat extra as an extra heat exchanger, that is the main heat recovery, total heat recovery, and we start to produce water between maybe 45 to 55 as the set point. So we are recovering that heat that we before were wasting into the environment. We recover that heat, we condensate, we use that heat recovery as a condenser, we condensate the refrigerant there, we come back to the suspension device, and we complete the cycle. In simple words, I like to say that sometimes it's like we have transformed a standard chiller into a water cooler, right? And this is because we're using all the heat that we were before wasting to the environment, we're using into the system, all right? Instead of one the cooling tower. This is only to give you an idea of what happened internally. And this is, keep in mind that this is the most efficient point of the Polyvalent heat pump, because basically you're using everything you were wasting. So by itself, the unit recognizes the requirement of heating and cooling. Let's say that you comply and you satisfy that demand of heating, and when you satisfy that demand of heating, I don't need to heat anymore. The unit by itself will say, I don't need heat, and in that moment, that four-wheel valve will redirect again that heat into the air-cooled condenser. Basically, we go back into the chiller demand. How that will look like into the water circuit. This is basically, if you see on the bottom, the same simulation. Now we have 100% demand of cooling, 100% demand of heating. Basically, you can see that the fans and the air-cooled condenser are now off, and we're cooling the circuit 1 and circuit 2, and we're taking all that heat to heat the water into the heating tank. I do also parentheses here. You can see this is a standard, let's say, diagram connection for the water system. But you also see here in the middle what we call the make-up boiler in the whole water tank. As I say, during the kind of refrigerant compressor type and everything we have inside this unit, the maximum temperature we can get out of the total heat recovery, in this case, the 6 here, is about 55 degrees. So if you are willing to use the system to replace boilers and you are not able to do any kind of compromise on temperature, you still need to do 70, 75, 80 degrees. You will need to use a make-up boiler to do that delta T to the top. The good thing is your energy efficiency of the bill is already going up. You're using all that energy you were wasting before, and now you're using the boiler in more and more less capacity and less time. So what happens if we do 50-50? Okay, in this case, look, we have shut down completely one of the circuits, and the other circuit is working 100% that of capacity. That means 50% of cooling, and the other 50% of heating is going to the reuse, and one circuit is down. But here, where is the magic of the EXP coming by RHOSS? When you can even have unbalanced loads or demands of heating and cooling in the same building. So look at that on the left. You have 50% demand of cooling, 100% demand of heating. By saying that, one circuit is working as a chiller, is cooling the water, the tank, and all that heat is being used to heat the hot water tank. But if you see, if I only use one circuit, I'm only getting 50% of the demand of the heating. So where do I get the other 50%? The controller say, look, I'm missing heating. So the controller by itself is reversing the cycle that I was playing on the next slide of the other circuit. So one circuit will be running as a chiller, the other circuit will be running as a heat pump. It's taking heat out of the environment and it's actually sending this to the hot water tank. Finally, but not least, we have automatic trade. Automatic, if you remember, we have certified the demand of cooling, we have certified the demand simultaneous of cooling and heating. But look at, could be the scenario that in winter, I only want using heat for the heat for the heating of the room. For any reason, I don't need cooling. So in that moment, I certify the temperature of my tank. The controller say, I don't need to use any more cold water, so I only need to produce heating. So what the controller does is reverse the cycle of the refrigerant, and we have transformed now the chiller into a heat pump and that circuit. As you see, now we are producing heat 45, 55 in the secondary heat exchanger, and that's go now to the condenser that previously was working as a cool condenser, but now you see here on the top right, we have a second expansion device, and we are using that condenser as an air-cooled evaporator. So now the gases get expanded inside of this new evaporator, air-cooled condenser. We are getting heat out of the environment into the refrigerant, we go into the compressor, and we complete the cycle. So now we are able to produce only heating. And in simple words, this is exactly how you produce in a 4-pi unit for only one unit. You can produce only cooling, heating and cooling, and only heating. I think that starts to give you a better idea of where we are producing 2 pies and 4 pies. This is how we're looking in the water circuit. 100% demand of heating. Both circuits will be running as heat pumps, reversible cycle, and we're taking care of the environment to heat the unit. If we only need 50%, we only run one circuit. We have covered what we call 4-pi system, all right? So now what is a 6-pi system? I think it's very clear that we're not talking about a water-cooled unit, all right? So now a 6-pi system is what we call an extra plus. We are able to get another heat exchanger that before we have the main heat exchanger that we call mainly the evaporator, we have the secondary heat exchanger that it works like a totally heat recovery of the unit, and we can install what we call the de-superheater or partial heat recovery straight out of the compressor. That gives you the possibility to produce water up to 70 degrees. You're gonna tell me, Aaron, before you were telling me we'll go up to 55, and now you're telling me we can go up to 70. Yeah, the truth is, as soon as you are the compressor, the gas temperature there are really close or well above 100 degrees. That is the reason we can get 70 degrees there, all right? So now, what is a 6-pi system? It's a polyvalent 4-pi heat point able to produce extra hot water at higher degrees, all right? This is an advantage. This is something plus. This is something that I like and I dislike at the same time. The reason is we can control in precision mode the temperatures on the main heat exchanger and the temperature on the secondary heat exchanger heat recovery. The problem with this superheater in this case is, if you see there, the hot water production is available only when the unit is working and according to the request from the user. That means that temperature is really stick to the behavior of the load system or what happened with the compressor load. That means, for example, if the compressor for any reason are working in partial load, you're probably going to get different temperatures at 70, or maybe lower. So this is a plus, but it's something that is difficult to control. It's not something that I want you to be reliable. Yeah, I want to have that. I'm going to have 45 kilowatt at 17 degrees. So it is something to keep in mind. Last but not least, also, I always talk to you about the automatic mode. We also have the select mode. I cannot forecast too many cases here in Australia when we are actually doing select mode. Select mode, in my opinion, is more used in Northern European countries when you really get into winter condition, maybe snow even at the city, and you are using a unit. Select mode, in simple words, mean that you're going to be forcing the unit only to produce hot water at any time. That means that on the main heat exchanger that before we were only producing cooling, we are forcing the unit always to work as a heat pump and produce heat. And of course, you will get the partial heat recovery and the total heat recovery into the other unit. So select mode means priority for hot water. It could be winter if you're using air conditioning. I'm mentioning that like European cities, but could be a special project when you really want to have the flexibility between cooling and heating for a period of time. You want to use only heating and you want to maximize that capacity. All right, by this day, I hope that you have a little bit more clear what does it mean to be 2 pipe, 4 pipe, 6 pipe, 2 pipe with domestic hot water, and what is the confusion with calling this unit 4 pipe. The current name we should call this unit, as you know, is polyvalent and multi-purpose unit. I do another parenthesis, is good things. We are, as I say, we are Eurovent certified all, and Eurovent now into an EXP system. Previously, Eurovent didn't have polyvalent units inside the brand, and that gives you also the consequence. Here in Australia, we're a little bit backwards in regards to energy efficiency. Europe always been on the top of that, one of the areas on top of that. And for example, MEPS Australia at the moment does not include EXP polyvalent system, right? So anyone can bring any kind of heat pump EXP without an energy target. Advantage as an important advantage, I don't need to certify anything, that's my lazy side, but I have more disadvantage. The main reason is because we are a fully certified unit and we are really efficient, and that means that my competitor or any other guy can bring any kind of unit without any certification, claiming that they can achieve any kind of COPs or energy efficiency in 4 pipes that are not being tested. Again, these are the bad news. The good news is Australia is reacting, has been in some meetings already that as a stakeholder, as a chiller manufacturer, and there is already a review on MEPS that's already included. We're looking for that reviews to be accepted, and hopefully by early next year, polyvalent units will be added to MEPS. And actually came with something amazing because actually they're calling this correctly, polyvalent units, right? I do another parenthesis, that is my experience in the market, and this is more targeted even to consultants, is about efficiency, all right? We're talking here about efficiency. We need to introduce a new term, what we call total efficiency ratio. The total efficiency ratio is no more than the cooling capacity and heating capacity divided by the power required to get those capacities, all right? So the graph you see on the right is, sorry, there is an European weather data. I got lazy, I copied from the European presentation, but the behavior will be something similar. In any country, you have the 4 seasons separated, unless you go to the tropic area, you're gonna have something like this. And that means when you are in the middle season, that means that you're producing hot water and chill water at the same time is when you have your period of better efficiency because you are reducing that energy you before were wasting. If you are only cooling and you have a demand for heating, you're wasting that energy and vice versa. I think this graph gives you a better idea of what happened there. Blue is cooling demand, red is heating demand, and TIR is what is efficiency. In any place you see a match between the blue and the red, the cooling and the heating, you see the highest value. For example, you go to number 7, you see 50 and 50% demand, the TER goes to 8. The same when you go to number 13, when you have 100% demand, you have number 8. But what I was saying about the standard efficiency is, yeah, COPs and point efficiencies, like we know COPs, ER, and TER are something important. But I really think that Australia needs to change their mindset and start to think about seasonal efficiency. That is really well used in Europe and sometimes even in the United States. What is that? Is because in Australia, we like when we say, yeah, do you have that chiller in an inverter version? I want an inverter compressor, I want an inverter screw, I want a centrifugal, I want a turbo core, because I can put my partial load at any time, decreasing the energy input that I'm giving to that machine. And after I get a little bit out of the equation, when they tell me, yeah, I want this inverter scroll, and this is the COP I want to match. And this is, as I say, I'm not an expert, I'm only a messenger of this kind of presentation and simulation and chiller. I can learn from everyone. But in my opinion, COP is only one point of the graph. And normally when you're selecting a COP, say I'm selecting this COP at design condition, you, in order to minimize the cost of the unit, you basically define that COP at your maximum working load, or very close. That means that at that moment, that chiller, that heat pump is working at, let's say, 100% capacity. That means that your inverter is doing nothing. You can give you a good COP at that more or less at the same level without an inverter compressor. The real advantage of having inverter facilities in between the chiller is the seasonal, that you can say, I'm in middle season, I'm entering winter, but I still have a demand of cooling. So my chiller is running 25, 30, 40%. So you calculate that with your weather data and you get your seasonal efficiency. That is when we start to see the real advantage of inverter. I know is not directly related to EXP. It will also apply to EXP, but it's something to keep in mind. Before even we move forward, it's something that I like of the forward thinking of RHOSS. As I told you, RHOSS started to develop, one of the pioneers, started to develop the kind of technology in the early 2000s. We have easily 18 plus years doing EXP system, more than 50 years a company, but doing EXP polyvalent units for more than 18 years. An EXP system, there are different ways to do it. Some days doing 4-way valves, some days no return valve. Is basically an European technology. So what you need to look is someone reliable on the controller that understands what happened, and of course, reliability on the construction. But one thing is to have an EXP unit, and one thing is to have an EXP system, all right? And this is when RHOSS started to think forward. They have been doing, at the moment, they're doing the final test on the lab. It was supposed to be released early this year. Okay, COVID-19 changed everything. But by late this year, we should have what we call an EXP system. What is the difference? You already have an EXP unit with all the controller, with all the advantages I told you that we can do and smart the simultaneous independent cooling and heating, right? But an EXP could happen that your building have unbalanced load. You may need, I don't know, 600 kilowatt of cooling, maybe 400 kilowatt of heating. When you select a heat pump, could be EXP and a standard heat pump, the cooling and the heating capacity are quite balanced. There is always more heating. Let's say you have 200 kilowatt of cooling, you may have 240 kilowatt of heating, but they're quite similar. What happens if you have 600 kilowatt of cooling, 400 kilowatt of heating? All right, in that moment, running only a 4-pi unit could be, it's a better efficient than doing independent system, boiler and chiller, but it could be not running at the best efficient point. So what we call EXP system, now we have developed what we call a smart sequencer. Sequencer is more a controller that will be connected to any unit and would allow you to connect not only EXP unit, probably could be connect standard chiller or standard heat pump. And that way, for example, if you need to cover maximum capacity, 600 kilowatt of cooling, 400 kilowatt of heating, you may run an EXP unit in full capacity, and you can go have 400 and 400, and the other 200 kilowatt you can run on a standard chiller. Don't know. Maybe it's a little bit cheaper to buy, capital cost. So this is exactly where the engineers, R&D department, are developing this kind of software, and that would allow you. Together, we can help you to design your EXP system as a building, not only as an equipment. So we'll keep you updated when those changes are coming, but I'm quite excited to that. And that's the idea I want to tell you with TechIN RHOSS, is basically we're always looking to give you something better. And now, I would like to do this small comparison. And this is, first thing it was the presentation of European also, but this is something that is very important and happened to Australia. Sadly enough, dislike to say no to an order as a sales guy, but as also an engineer. And we're getting into problems and actually generating the necessity to do this kind of webinar when the market is confused. Because we are not calling this at the current number. We are not calling this polyvalent. We are not calling this multipurpose. So we got a specification when it was specified a reversible heat pump. All right, a reversible heat pump is a standard heat pump. A reversible heat pump with heat recovery. That was what it's called. All right, but we know that a reversible heat pump with a heat recovery standard controller is not the same like a polyvalent EXP heat pump. All right. The critical bit is data sheets are quite similar, 95%. So if you don't know what you're reading, you can be selecting actually a reversible heat pump with heat recovery instead of a 4-pi in data sheets. But the real disaster is going to be on site when you need independent cooling or heating, all right? Or vice versa. As I told you, if I need heating and I don't have a demand of cooling or heating in the primary circuit, I may not be able to get that heating. The problem is because you're saving a lot of money in control type, in four-way valves, in all the accessories you need to have to do the reverse cycles and do everything. Yeah, and a standard reversible heat pump and reheat recovery will be cheaper. Actually, this contractor was about to send the order to us because we were more cost effective. But yeah, we are really cost effective as a brand. We know what we're doing. But once is when it was too good to be true. So we checked with the engineer and said they're interest 2 months about the contractor. Like we're getting something out of the blue. Request for the spec. Analyze myself. Yeah, it wasn't specified by the name polyvalent or multi-purpose, but at the moment you see it and you read the specification, it was pretty clear that it was a polyvalent system required. So we could sell the unit. We tried to advise the contractor that we're doing the wrong decision, but they say, even starting from the consultant, that it was called reversible heat pump. We pull out. I don't know exactly what happened, but if they go for another supplier, reversible heat pump with heat recovery, they're going to have a lot of issues. So this is something, if you are listening as a consultant, as a contractor, important as a consultant to start to call the things by their name, but actually to know what is really happening there. So this is exactly when you need to think. And yeah, an EXP, it a polyvalent unit, multi-purpose unit. Yeah, it is a heat pump with reversible cycle with heat recovery, with a smart controller and with a smart valve. That's different. Every manufacturer will have different names for their own technology, but if you start to call this by the correct technical surname or name, polyvalent multipurpose, it will be easy to organize. But now, why? That doesn't mean that you always need to use an EXP unit. The EXP unit will cover all these scenarios, but could be some areas of that cake that you can cover maybe with a heat pump. With a total heat recovery, it will give you some savings in money. If you really know what you're doing, of course, and you didn't know the consequences. That's the reason we are comparing that. So if the system is a 4-pipe system, that you now understand what's a 4-pipe system, you need to go polyvalent. You need to go EXP 100%. But let's say you have a requirement where you need a top pipe, 2-pipe with heat recovery. The good thing is, for example, with us, now we have what we call a new generation of heat pump, smart heat pumps. In other words, we are able to supply even hot water on the recovery without the demand of the primary sometime. But that will have some risk. This is a scenario of that a smart heat pump in summer month can work as a chiller that will give you cold water, in winter month will give you hot water. When we are producing independent water on domestic water heat recovery, we started to get a risk. Something that even in Australia we may not be aware or we may not be used of what happened with a heat pump. All right? When we're using a heat pump, normally in winter, let's say it's a cool heat pump, we're taking heat out of the environment and we're heating the rooms and we're heating the water to get into some kind of system. But maybe your ambient is 5, 2 degrees, 10 degrees, and if we're running those temperatures in ambient, the refrigerant could be running by the dispensing device going into that condenser that is now working as evaporator, really lower temperatures. And regarding the humidity you have in the environment, you can start to produce frost. You can start to frost the condenser fins itself externally. And that will be continue growing on the even can block. That is the reason any heat pump will have what we call a defrost cycle. That defrost cycle, I will explain you in the future how we do it. But basically, yeah, we reverse the cycle and we heat the condenser. We work like a chiller and we defrost the condenser. The problem is, in an EXP system, you have independent circuit, independent cycles. The unit by itself can decide to do defrost in the primary on the secondary range without any issue. Meanwhile, when that's the warning, you start to get in this kind of system. You see that one when you're running winter defrost on primary side. The unit maintains a correct temperature on the primary side to permit defrost. So if the primary side is going to defrost, you're not going to have any issue. But if the secondary going to defrost, you can be actually taking those temperatures even lower, and you're going to start to frost more the fins, and the system will stop. Probably the system will have a 3 automatically reset alarm, stop, start, stop, start. You gotta get an alarm, the system stop. You need to go there, check, maybe clean the fins, remove the eyes, and start the unit. But if you start to do this too often, you even have the risk to damage. So this is the kind of situation where you start to see, oh, the advantage of having an EXP unit. So if you know what you're doing, you know the humidity of the area, you may save a few thousand or a few $100s on the chiller, on the EXP, but you have this kind of issue. And of course, you can have simultaneous on generation of hot water and cold water. So I hope this gives you a bit of the idea what happened. And you need a 4-pipe system, please go with a 4-pipe system. And this is something we can study case by case. So as an advice, it's like that. As simple as that. If you are designing a 4-pipe system, that means simultaneous cooling, heating, or independent cooling or heating, you need a 4-pipe unit. We can evaluate together, we can help you to look for better solution with 2 pipes, with heat recovery, and we can analyze to your project this is suitable or not. You may save too much money or not, but keep that in mind. And please, when you do a specification, you are pretty sure, call this correctly. Don't call it reversible heat pumps because there are no reversible standard heat pumps. You need to call it polyvalent. That actually makes sure that your project will be 100% protected. Last but not least, show you a little bit of the range. We have one of the biggest range in this industry regarding EXP unit. We can go up to 700 kilowatt on the air cool. We have a new range with inverter scroll compressor. It goes about 140 kilowatt, one of the biggest range in inverter scroll. There are too many manufacturers saying a lot that we have inverter scroll chillers or heat pumps, but we are one of the few to have inverter scroll and EXP polyvalent units. And we also have a water cool EXP units, all right, up to 450 kilowatt. To finalize, this is only a nutshell of the information. There are many things you need to consider, but I always highlight something very important. When we have, and starting in Europe, and even have some reference not only for us, and I started to hear some guys, I don't like to use 4-pipe units, they misbehave. Right. As a manufacturer, as a chiller manufacturer, heat pump, in my experience, I can say at least 70% when we get someone getting an alarm or someone, it is an installation issue, all right? First thing, we have been doing chiller for so many years. It's the same chiller that I've been doing for all the manufacturing line. It's tested, the European certified. Every chiller manufacturer, in fact, they made a mistake. We're the one who raise their hand and say, look, we're gonna mistake. We gotta fix it, but we operate our mind. So one of the main things or the main issue when you are designing a 4-pipe unit is the minimum water volume, all right? And more important for the heating water side. But both are important, but it's really important. If you underestimate the volume, you go with a smaller volume, remember that this unit automatically is swapping between cooling water, simultaneous heating. So if it's too small, the water volume, and we're getting those temperatures too quick, the chiller or the EXP polyvalent unit can start to misbehave, swapping between modes and doing whatever crazy they can do because they don't know what to do. You don't give them enough time to react. One of the things. So the minimum volume recommended, okay, you go to our manuals, it will be more detailed, but please consider as a general rule 10 liters per kilowatt. That gives you a good safe area to work with. So this is the kind of information we can help you to build, and this is when you need to start. For example, when we remember talking about 6-pipe, look at this baby unit here. You see 6-pipe connection there, but that's not a 6-pipe unit. That is basically a 4-pipe unit, cooling, heating, and the other one is a condensed water. That is going to be caused as a water cooled unit. This is the kind of trying to understand what it means. 4-pipe, sadly enough, is how the system got to code generally. It's like when you go into Bonnie's and you want to look for a box with put your eyes and your beer to go to the beach, you get to give me an ST. But ST is the brand. Right? So the same thing, 4-pipe. I don't like to call it 4-pipe, please call it polyvalent or multi-purpose. All right? The EXP units can be joined to any of our accessories, like, yeah, we all know AC fan, high static pressure fan. We have different type way to reduce the noise management. We have energy efficient optimization. We have variable primary flow. We use our own system. That could be another presentation. We do things like adaptive function plus. That is basically a way to control, change the set point of the temperature to match what is the actual demand of your building and saving energy. We can work in any chiller in adaptive function plus that we call an economy, or we can work by precision. But it's basically I want 7 degrees and we produce 7 degrees. That is basically that with this. All right. So you know where we are. You know where to contact us. You can send an email to myself, to Rob, to Brendan, Scott, Dion, in English, right, depending on the area where you are. But if you, for any case, get confused, send it to anyone. We are pretty close. We know what we're doing, and we will redirect you when it's necessary. But if you want technical advice on RHOSS on TechIN, that is basically your headquarters for chillers or heat pump here in Australia, feel free to contact me at any time. I hope the webinar, these videos, is useful. I apologize because I need to actually re-record it because we have system issues. In the last one, this is my computer actually go frozen for a while, so that's the reason we actually re-record it. Feel free to contact us, and please take care of our websites or new, follow us on LinkedIn, because we're going to be doing more webinars like this in different areas. There are 2 coming very soon. That will be regarding infection control and operating theaters, and one will be high-density data center. When you don't need to use in-route technology, you use another type of technology coming out of America, New York, and you can go anything between 12 kilowatt to 75 kilowatt of high-density rack cooling. Very interesting. LinkedIn is now using those kind of units in their data centers. All right, thank you guys, and I hope you enjoy this.